One of my wonderful subscribers recommended this book. I got a cheap copy. It does have a matching topics in matrix analysis, a second book, which is a lot more specific. Right now, all the copies that I can see are $60, so I'm going to stick to just having this one. And this completes sort of like a trilogy of applied linear algebra books beyond what an Anton book would do. So these are really more specific. And so you'll see in my channel there are videos for the other two. The Agarwal book is for data science. It's a lot more modern of the three. Then the other one, I forget the name of the authors, was a major book. Is really kind of like a computer science book masquerading as a linear algebra book. This one is like an analysis book masquerading as a linear algebra book. So I think between those three books, I know I'm not going to have the time in the current cycle. I think I'm going to move on to abstract algebra a few months from now. But as of now, yeah, I'm not ready to tackle any of these books. But now I have three, and I think that's plenty for an applied linear algebra course, or like spending some time on it as a hobby. But I'm not there yet in my case. But if any of you all are interested, yeah, there's two more videos before this one. This is the third one. So the book's got 9 chapters, but one is numbered 0. And it's really because this is not your first linear algebra book. This is a linear algebra book that looks at linear algebra from all the different parts of linear algebra that could be applied in things with analysis in it. A lot of differential equations, partial differential equations I see throughout the book. I had time to sit and wait at a doctor's office, and early this morning, so I had time. Well, whenever this video comes out, it's not going to be the day that I'm filming it, but it so happens that I had a good hour to go through in gory detail and query Wikipedia for some things. So basically, it's got the thing that says, okay, this is the basic linear algebra you need to know. Then it goes straight into eigenvalues, eigenvectors, and similarity, SVD, right? And then unitary equivalence and normal matrices. And I'll go through each one of these chapters. And then canonical forms. It's got a whole chapter on canonical forms very early in the book. Then Hermitian and symmetric matrices, norms of vectors and matrices, location and perturbation of eigenvalues. This is heavy-duty differential equation stuff. Positive definite matrices, and non-negative matrices. And then it's got a few appendices, including Weierstrass theorem, of course. Again, as I said, it's almost like an analysis book masquerading as a linear algebra book, which is great. I love analysis. And so it's got a great preface where he mentions, topics and matrix analysis, very specific chapters on specific topics, because of course it sort of would be the way you can branch out into all these very special topics and that are still very hot today, I'm sure. I mean, linear algebra is a massive field. Of course, your chapter 0. And I'm going to page through this book a lot more than I usually do for a book, because I really like it, and I had the time to go through it earlier today. So it's got all your basics for what you should have learned by the time you got to this book, basically. And one of the things that I noticed was, so once you hit once you stop here, from here on out, these are all very special types of matrices that I don't think are covered in most beginner linear algebra books, or even the theory ones. So these are very specific, I would call it engineering subfields that use specific matrices. So for example, permutation matrices, circular matrices, where you have these cycles of 1s and 0s that are in the diagonal. They have a name, I'm sorry. Anyways, they have 1s and 0s. Then Toeplitz matrices, and then Hankel matrices, Hessenberg matrices, tridiagonal matrices, matrices and Lagrange interpolation. So once you get into the specific chapters, these beginning ones are not going into the applications yet. So this is really a chapter about similarity. Similarity gets really good treatment in here. Yeah, there you go, similarity. Including a little bit of SVD. I saw SVD, but the SVD gets heavier treatment later on in the book. Then when you go to chapter 2, okay, this is unitary matrices, a lot of normal matrices. Yeah. It's laying out the different types of matrices and all the theorems that will be used throughout the rest of the book. Of course, one thing that I noticed is this is why this little marker came with the book. One thing that I noticed was it also does something that I really like, which is give you an argument for a proof and say, hey, what's wrong with this argument? I really like that. It does that. I noticed that. I always like it when a book does that. Then in chapter 3, again, and it's got a lot of problems. It could have a few more examples, but it has a lot of problems. And a lot of theorems and a lot of proofs. QR factorization, remember that. And then, of course, the chapter on canonical forms. One thing that I really liked about this chapter is that it's got a proof for the Jordan canonical form. Goes through a lemma, lays out a theorem, and then just goes through a proof. So, yeah, a proof of the Jordan canonical form. So this book had me at hello when it did that. And it explains it really, really well. So I think when I get to the Jordan canonical form in Freeburg, Insil, Spence, I'll be looking through this book. This will become one of my reference books for sure. Loving analysis and seeing how much I'm enjoying linear algebra, it's totally a twofer. Then when you get down to chapter 4, this is where you start seeing your differential equations, your Hessians, yeah, a lot of differential equations applications. And so in this case, actually, if I ever get around to reading through this book, which would be a candidate for sure, I would love to read through this book someday. I would wait until I do some ordinary differential equations and partial differential equations, and then maybe do like a new like a strang linear algebra just to refresh myself. It'd be a bunch of books that I would read, 3 or 4, and then I would be ready to really tackle. Because yes, it is true, you don't need to do that if you know enough differential equations. You just read the book and that's it. But it's a lot better. I know this for a fact. It's happening to me with FIS, with Freeburg, Insil, Spence. That because I just went through Anton, now when I'm in FIS, I'm like, oh yeah, I just did that. I get it. I just did a bunch of problems like that. So it'd be really nice. I think in my case, I would go through a basic linear algebra book, ODE, PDE, and then do this book. I mean, it's got a lot of heavy-duty stuff that really, if you're fresh from oh, and also some Fourier analysis for sure. And that I think gets discussed in later chapters, and even a little bit of analysis too. It wouldn't hurt to have like a couple of weeks of refreshing myself through all the theorems of real and complex analysis. I don't know. Maybe I'm expanding the list of books that I want to read before this book too long, but I'm just saying. I'm just going by what I'm seeing. Yeah, norms. So it is necessary for a proper formulation of notions such as power series of matrices. Sounds like fun. And it is essential in the analysis and assessment of algorithms for numerical computations. So this would be a chapter that's really kind of going to the computer science applications of linear algebra. Norms and more norms. Then when you get down to chapter 6, and yes, I am taking my time with this book because I think this book is a jewel. Then for chapter 6, and of course, linear algebra these days is a behemoth of a field. I mean, it's just with all this AI stuff, and the field was already pretty big, but now I think it's just, in my opinion, it's exploded in the last decade. So yeah, this is more differential equation stuff. Stability of oscillating systems. And then, of course, some left half plane in the complex plane. So this is really differential equations, but with complex numbers included. So this thing called Gaussian disks, which I had never heard of this term. Yeah, and I'm sure I'm butchering this name. I'm sure it's pronounced some other way. Yeah, perturbation theorems. It's hardcore. This is hardcore linear algebra, which is great. Then chapter 7 gets into statistical variance, covariance matrices. So it goes into the least squares, but also including Taylor series. Yeah, positive, definitive, definite matrices. Yeah, and then here we go. So this is the money shot. So this is where SVD gets discussed, section 7.3. Yeah. Examples and applications of SVD. I can see those omegas, I'm sorry, the sigmas for singular values. Sure product theorem. Yeah. Then now when you get down to chapter 8 is non-negative matrices. It's got a little traffic flow example. And it's got some references, but he says it in the book. Look, I'm not going to go crazy on the references because I don't want to make the book too long, but I was looking through these references and I saw some very interesting books. Specifically, ones that I'll be on the lookout for are Marcus, Finite Dimensional Multilinear Algebra in 2 volumes. Boy, looked it up. The only copies that I can find are very expensive. This happens sometimes when I look for references for obscure books. There you have it. That is Horn and Johnson.